All right, I'm going to do June of 2017. I'm going to do it on separate pieces of paper because the last exam I did both in the book and on paper, and it was twice as much work for me. So I'm going to try and do it all on the paper this time. To keep track of his profits, the owner of a carnival booth decided to model his ticket sales on a graph. He found that his profits only declined when he sold between 10 and 40. So that's the key. It's declining between 10 and 40. Which graph should represent his profits? So here's what I'm looking for. I don't know what's happening on either side, but between 10 and 40, I'm expecting to see something like this. Okay? So which of these graphs has a downward trend between 10 and 40? Here's 10 and 40, 10 and 40, 10 and 40, 10 and 40. The only one that goes down in that time is right here, choice 3. Okay. Number 2, the formula for the surface area right rectangular prism is A equals 2, and that might look like an I, but it's a 2LW plus 2HW. I'm going to use capital letters so I don't confuse you. And 2LH, where L, W, and H represent length, width, height, respectively. Which term of this formula is not dependent on the height? Okay, when it says which term, you're talking about 3 individual terms that are going on here. The term also includes the sign in front, but I didn't want my boxes to touch. It says which one does not depend on the height? Well, that one depends on height. That one depends on height. Right? So anything that has height in it, like 2HW and 2LW or LH, those are gone. And A depends on all 3 of these, right? If any one of these 3 changes, then that's going to affect A, because they affect A. So the only one that doesn't is 2LW. Right? Number 3, which graph represents the square root of x minus 2? Just go to your calculator, turn it on, go to y equals, and type in square root of x minus 2, and you should have absolutely no problem identifying which graph this looks like. Choice 4. These real quick. Okay. Moving on. Number 4. The student plotted the data from a sleep study as shown in the graph. The student used the equation of the line y equals negative 0.09x plus 9.24 to model the data. What does the rate of change represent in the terms of those data? Rate of change is the part that's attached to the x. And by the way, a triangle is a symbol for the word change. So the rate of change is negative 0.09. Negative 0.09 is attached to the x, but its label would be like if we were looking at slope. Remember how we did y2 minus y1 over x2 minus x1? Its label would be the y per the x. So let me look at what the label is on the y. It says average number of hours of sleep per day. Average number of hours sleep per day. And the x value is age. So I'm looking for something about average number of hours per age, or given their age. So let's see. Average number of hours of sleep per day increases. Well, it's certainly not increasing because the number was a negative number. It's not choice 1. Average number of hours of sleep decreases. Okay, that's possible. And I know it's not the 9.24 because that's not the rate of change. So by process of elimination, it is number 2. Number 5. Lynn, Jude, Ann were given the function f of x equaling negative 2x squared plus 32, and were asked to find f of 3. Lynn's answer was 14, Jude's was 4, and Ann's was 4, plus or minus 4. Who is correct? All right, we know very well that I can do this easily just by using the storing method. So I go to my calculator, and I take 3 and store it in for x. You can't see that here, can you? Is that helpful? Yeah, you can see a little bit better. One more time. There, that's better. If I store 3 in for x and I type in negative 2x squared plus 32, my answer is 14. So again, go through the process to see who in fact gave the right answer. 14 would be Lynn, so Lynn only, choice 1. Number 6. Which expression is equivalent? In order to be equivalent, then you have to have matching tables. That's the way we've been doing it, considering we haven't had a lot of time for curriculum. So let's go back to our matching tables. It does not matter what your x value is. You'll notice that a lot of mine started at negative 3. That's just because my calculator was at negative 3. It doesn't matter. So my original is negative 16, no, not negative, sorry, 16x to the 4th minus, oops, over there, minus 64. I'm going to type in each of my choices. So I've got parenthesis 4x squared minus 8 squared. I've got 8x squared minus 32 squared. I've got 4x squared plus 8 times 4x squared minus 8. And then I have 8x squared plus 32 times 8x squared minus 32. Alright. So your calculators are more than likely at 0. I'll change this so that 0 is at the top. I'm going to go back and look at just the 0. Sorry about that. At 0, my first column is negative 64. Then 64, then 1024, then negative 64, and the last one is negative 1024. Well, I don't have to look very far to see that since y1 was my original, the choice that's in pink, it's the pink, is the one that matches. Okay, let me get this situated. The choice that's in pink is the one that matches. If you can't remember which one you typed in, go back to your y equals and see which one is written in the pink. That would be the 4x squared plus 8 and 4x squared minus 8. Alright, choice 3. That is equivalent. Alright, moving on. I apologize for my writing. It is messy when I'm in a hurry. And I'm only in a hurry because my internet takes forever to load long videos. I'm doing my best for you. Alright. Number 7. Vinny collects population data about a specific strain of bacteria over time in hours each, as shown in the graph. Which equation represents the graph? So a couple things I'm going to do. I'm going to actually type this in the calculator just to double check. But I know for a fact that it's not 2 because 2 is a line. There's no square, there's no exponents. So because of that, this is not linear. If you didn't realize that, then there's no harm typing them all in. So here's what I'm going to do. I've got 4 parentheses 2, and remember, if I'm on the screen, I'm going to use an X, not an H. I've got the fraction 46 over 5, followed by an X, plus the fraction 6 over 5. Then I've got 3x squared plus 0.2x plus 4.2. And then finally I've got 2/3 x cubed minus x squared plus 3x plus 4. I need to get that other one out of there though. Now I want to make sure that this graph is entirely accurate. So I'm going to go to my window and I'm going to change my window based on this. It goes from -5 to 5. And my y value goes from -1. Oops. My y value goes from -1 to positive, let's see, that's 32. And this one's 4. They're going up by 4, so that goes up to a 36. We're counting by 4s, so when it says scale, I'm going to put 4 there. Alright, choice 1 crossed at 4, and it's going up, so choice 1 looks pretty good. The red, definitely not the red, so this was blue, red, black, and then yellow. The black looks pretty close. And the pink is a definitely not. So, which equation represents the graph? Okay. We need to check a couple of these numbers just to be sure. And we're going to check the blue and the black. Okay. At 0, the blue and the black, well, the blue is 4 and the black is 4.2. At 1, the black is 8. Or the blue is 8, the black is 7.4. At 2, the blue is 16, the black is 16.6. So this one is the one that is closest, choice 1. Alright, 7 is going to be choice 1. I'm just going to write calculator and graph. The table to check. Number 8. What's the solution? Alright, so this one is going to be something that we would encounter later in the chapters, but there is a way to figure this out in a multiple choice context. I want to look at all of my choices. I'm going to write them down. Choice 1 is none. Choice 2 is infinite. Choice 3 is -1/6. And choice 4 is 1/2, 9. I'm going to check I'm going to check choices 3 and 4. And here's what I know. If 3 works, that could be the answer. If 4 also works, then it has to be choice 2. If 3 doesn't work, then I know it's not infinite and it's not 3. If 4 also doesn't work, then it has to be no solution because there's no other choice on here. So I go into my regular screen. I'm going to save -1 in for x, and I'm going to type in 6 for y, and I'm going to do this a little bit differently than I did with the last exam. In order for a solution to be the solution to the system, it's got to be the solution to the first and the second. So here's what I'm going to do. Type the first exactly how I see it. Whoops. Let's try that again. Y equals 2x plus 8. And then if you remember, if you go back to second math again, over to logic, the word and is right there. So I want to make sure that this works for both. Alright, -1/6 did not work for both, which means it also can't have infinite answers. It can't have every single answer if one of them doesn't work. Now let me check. You do 1/2 or 0.5 in for x and 9 in for y. Go back up to that statement. It does not work for that point either. So if it doesn't work for this one or this one, then it can't be infinite. It has to be none because there's no other option. Okay, answer choice 1. Number 9. A mapping is shown in the diagram. The mapping is a function, non-function, da da da. Okay, so remember, in order to be a function, no repeating x's. Mappings are sometimes difficult to identify the x's and y's, so I'm going to write them down separately here. With January, I am mapped to 31. With February, I am mapped to 28, and I am mapped to 29. With March, I am mapped to 31, and with April, I'm mapped to 30. Hopefully when you see it written that way, you can see that we have repeating x values. February showed up once, so it is not a function. Let's look at our choices. Is it a function? Nope, not choices 1 or 2. Okay. Not a function because February has 2 outputs. There we go. Answer is 3. Number 10. Which polynomial has zeros? Okay, zeros are also roots. So what I'm going to do is graph each one of these and see which one has roots at -3, 0, and 4. Now if you remember, I already graphed and I changed my window. If I ever want to go back to a regular window, then go to Zoom, Standard. That brings you back to the standard 10 by 10 window. Okay. So let me put in my choices here. In choice 1, I'm going to type in x plus 3 times x squared plus 4. In choice 2, I'm going to type in x squared minus 3, oops, and x minus 4. In choice 3, I'm going to type in x times x plus 3 times x minus 4. And in choice 4, I'm going to type in x minus 3, and x plus 4. Okay. And I'm looking for the roots at those numbers. Okay, blue has a root at -3. But I don't see it having a root anywhere else that I need. Red does not have a root at -3. Black has a root at -3, 0, and 4. And pink does not have a root at -3. So just by looking at the graphs, I know that the answer has to be choice 3. Okay. Number 11. Jordan works for a landscape company during his summer vacation. He is paid $12 per hour for mowing lawns. $14 per hour. I should have written per hour. Planting gardens. He can work a maximum of 40 hours. And would like to earn at least $250. All right. We're using M for mowing. We're using G for planting gardens. I'm going to do this part first. Okay. When he mows he gets $12 per hour, and M is the number of hours that he's mowing. So let's say he mows for 1 hour. He makes $12. If he mows for 2 hours, he makes $24. Well, how do I get that? 12 times 2. 12 times M. He's also making $14 every hour that he gardens. And if he wants at least 250, then that means he wants to be 250, or he wants to make, and this is the money that he's making right here, he wants to make more than that. Okay, so before I continue anywhere else, I'm going to see which of those has that statement. 3 and 2 have the inequality symbol the wrong way. Okay. Now for hours, M and G stand for his hours. He can work 40 hours max, which means he can work 40 hours, but he can also work less than 40 hours. And that would be choice 1. Number 12. Annie invested $1,000 in an account with 1.3% annual interest, no deposits or withdrawals, 2 years. Compounded annually. Compounded annually, you've got the formula A equals P times 1 plus R to the T. How do I know that? Well, that comes later in the semester, so just trust me on that. This is the formula for interest that we're going to use in this course. P is your principal. That's the amount you start with. R is your rate, but it's not your rate as a percentage, it's your rate as a decimal, which means you take your decimal point and move it 2 to the left. And T is time in years. If I throw this into the calculator, well, I don't have to throw it into the calculator. I just look at my choices. It's definitely not choices 3 or 4 because the decimal point's in the wrong spot. And it is an addition because we're making money. So it's choice 2. Which value would be a solution? So use the storing option. If it's a solution, then if I store it into x and type the inequality 47 minus 4x, and I match that symbol, which is choice 5, it did not work with the first one. If I store in -10, it does not work with -10. If I store in +10, it does not work. If I store in 11, it does work. Choice 4. Store and check. We came out with an answer of choice 4. All right, number 14. Bella received data or recorded data and used her graphing calculator to find the equation of the line of best fit. She then used the correlation coefficient to determine the strength of the linear factor. Which correlation represents the strongest? Okay. Which coefficient? Correlation coefficient. So a correlation coefficient is an R value, and it's on a scale from -1 to +1. If you're at a correlation cofactor or correlation coefficient of 0, that means you have nothing, that your points are not connected whatsoever. Like a graph might look like this. They have nothing in common, they're kind of all spread over the place. However, the further out you go toward 1 being 100%, it's strong. You can be strong positive or you can be strong negative. For example, strong positive would be if I eat more, I gain more weight. A strong negative would be if I work out more, I lose weight. Okay, so those are very very highly connected, strong. In this case, strong would be anything that's close to 1, which would be either 0.9 or negative 0.8. It doesn't matter if it's positive or negative. Okay? Positive 0.9 is closer to positive 1 than negative 0.8 is to negative 1. All right? 15. Heights in inches, 12 students. In order to do this, I'm going to show you a different piece of the calculator that actually works with this kind of information really well. If you see median, that's a good clue to go use this information. So I'm going to actually type in or write down my notes of what I'm going to type in. So I'm going to go to stat. Okay, and then I'm going to edit a list. Press enter on that. And I'm going to put my values into L1. Now I currently have stuff in my columns, so if you go up to the top and press clear down, they go away. Go up to the top, press clear down, and they go away. And I'm going to put each of these data values in L1. 67, or 61, 67, 72, 62, 65, 59, 60, 79, 60, 61, 64, 63. And if I go back to stat, then if I want to figure out mean, median, all that stuff, I'm going to calculate one variable statistics. I only have one variable to worry about, and that's heights. That's what it says in the problem. So one variable stats. If you press enter, just confirm that your list is in L1, and it is. If I press enter, then all of this data is going to show up, and this data has very important connections to what we're talking about here. I'm going to skip where it says spread for a second. I'm going to go right to the next portion where it says median. The median is down here. If you scroll down, it says MED, M-E-D. The median is 62.5. Now it says here that it's 59.5. That's not true. It says it's skewed because 59 is the only value below 60. We'll talk about that and outliers here in a second. But evenly spread. Evenly spread would, I don't even know really what they mean by that, but your spread could be range, your spread could be standard deviation. If you go up to the top, standard deviation is right here, either this S or this whistle looking symbol, and it says 5.9 and 5.6 if you go down now. That would mean that you would be going 5.6 or 5.9 away before you get to your next, what's called a quartile. So here's what the quartiles are. I'm going to draw a graph here. Not that kind of graph. Okay. The lowest number in this data set is 59. The highest number in this data set is 79. The median, let's say that that's 69 right there. The median, that middle number that we just found, was 62.5, which is right about here. Okay, if you're not sure, then between 59 and 69 would be 5 away from that, so 64. It'd be right about here. Now the other thing I need to do to draw this graph is figure out my quartiles, and these are labeled as Q1 and Q2, or Q1 and Q3. Q1 is 60.5, which is going to be right about here, and Q3 is 66, which would be right about here. And we make a box with the middle 3 and whiskers with the outside 2. That's why it's called a box and whisker plot. Now the question says something about outliers. It says 79 is an outlier which would affect the standard deviation. I'm going to say that that is true, and I'm going to show you why it's true here in a second. It's not skewed because 59 is the only value under 60. 59 is pretty closely connected with these values. I don't think it's just the 59 that's pulling in this direction, but here's what they mean by outlier. An outlier is found when it's outside of 1.5 times what's called the interquartile range. The interquartile range is this and this number subtracted. Okay, this number and this number. Those two numbers were 60.5 and 66. In other words, it's 5.5 times 1.5. Do some quick calculations here. 1.5 times 5.5, and I get 8.25. Well, what's significant about 8.25? If you go 8.25 from the median, okay, then you're reaching what's the majority of your data. The median here was, again, 62.5, I think. Yes, 62.5. So if I take 62.5 and I go 8.25 less and 8.25 more, 62.5 minus 8.25 gives me 54.25, and 62.25 plus 8.25 gives me 70.75. That means that my data should fall between those numbers, 54.25 and 70.25. 79 is outside of that interval, so 79 is in fact what's called an outlier. I'm going to go with that number, choice 4. It is an outlier, and it skews our data. Skew means pulls in a direction, pulls it from its norm. The graph of the quadratic function is shown. We're going to figure out what that graph is based on some pieces of information. Well, here's what you need to know for number 16. Is this opening up or down? This is opening down, which means it's going to be a negative graph. Okay, I'm going to get rid of 1 and 3. You can also type these into your calculator if you want to be double check the answers, but here's what I do know. Of the two graphs, my y value is 25. My y value is going to be the number at the end. So it's got to be choice 4. Again, you could graph all of those and make a wise decision using your tables. Well, not tables, but yes, you could use your tables, but your graphs and comparing them. Which statement is true about the quadratic function g of x shown in the table, and this one? All right, this, just like the last example, is written in what's called vertex form. I didn't talk about it in the last example, but I'm going to talk about it here. The number on the inside is the x value of your vertex, which is your turning point. In this case, it's a quadratic. It looks like a U because of the 2, right? It'll look like this. Or it could look upside down. This one's right side up because it's positive. Now here's the thing. If it's in parentheses, you actually have to do the opposite because parentheses lie. So if that says -3, then actually we're looking at a positive 3. The number on the outside is not in parentheses, so we use that as the y value for the vertex. In the last example, the vertex would have been at 15, positive 15, positive 25. But because 15 is the x value, it would be negative inside the parentheses. Choice 4. All right, but going back to this. So the vertex is 3, 2. The vertex of the other graph is the one that doesn't match when they're written in y values in order like that. So the vertex is 3, -5. Do they have the same vertex? No, they have different y values, so it's not choice 1. Do they have the same zeros? Well, we'll talk about that in a minute. Do they have the same axis of symmetry? The axis of symmetry is a line that goes through the center of the graph. Well, that's an x-valued line, meaning that anything that's vertical is of the form x equals whatever number. But what do you notice about their x values? Because their x values are equal, they both have the same x values, they're on the same line. Then yes, that is the answer. They have the same axis of symmetry. Choice 3. You can fold them in the same spot. You can see from my writing, I'm getting a little impatient here. This is hard to do. 19. Nope, we're on 18, aren't we? Yep, 18. Given the function f of n, and we know f of 1 equals 2, and we know f of n equals negative 5 f of n minus 1 plus 2, which could represent the range. Okay, so here's what I know for certain, and I'm going to treat it like a table of values. I know that the point, I know that the point 1, 2 is the first point. Okay, I also know that I find the rest of my points with this formula right here, which says take the previous. Now think about this. If this number was, say, 10, then this number would be 9, right? 10 minus 1. So to find my number, I use my previous number. All right, this is what I mean. To find my next answer, I take negative 5 times the previous answer plus 2. Negative 10 plus 2 is negative 8. To find this answer, I take negative 5 times the previous answer plus 2. To find this answer, I take negative 5 times the previous answer plus 2. Negative 210 plus 2 would be negative 2, 8. And then so on and so forth. I don't want to calculate that. It's too big for me. So, which one matches? 2, negative 8. It's got to be this one. All right, I see the list right there. Okay. An equation, the solution. Okay, so number 19, we're talking about solutions again. Anytime I see the answer, or I see the word solution, if I see solution, I think store. I'm going to store each one of my answers until I get one that works. Okay, starting with 8.3. If I store that into x, and I type in 4 times x minus 7 equal to 0.3 times x plus 2 plus 2.11, it comes out as an answer. I'm going to double check all of them though. It's not that one. It's not that one. Oops. It's not that one. It's got to be choice 1 by basis of storing and checking. $20 needs to move 120 feet. Cubed wheelbarrow load holds 8 feet cubed of dirt. Each load, one correct answer to figure out the number of hours. Okay, so here's what I'm going to do. And I apologize because this one will not be on the paper. I'm going to do this one completely in the book. First thing I want to do is look at these extended proportions. That's what they're called. Well, I guess they're not extended, it doesn't say equal, but these fractions. And I'm going to cross out numerators and denominators that match. For example, in choice 1, I have load in the bottom and load in the top. I have feet cubed in the bottom and feet cubed in the top. It doesn't matter what bottom, it doesn't matter what top, okay? Over here, I've got minute and minute. Over here, I've got load and load. And over here, I've got feet cubed, I've got load, and I've got minute. Okay? The question wants to know one correct way to figure out the number of hours. So I'm looking for something that's left with just hours. And if you look at choice 4, everything canceled except for that final label of hours. So number 4 is going to be my answer. Number 21, what do we know about linear functions? Equal factors over equal intervals, unequal factors over equal intervals, equal differences over equal intervals, unequal differences over equal intervals. Factors imply multiplication. Differences imply addition, subtraction. So multiplication, division, or addition, subtraction. Linear functions are based on addition, subtraction. So I already know that it's not choices 1 or 2. I also know that I have to move the same amount every time for it to be a linear function. For example, we're familiar with slopes going up 1 over 2, up 1 over 2 up. You're saying the same thing over and over. So those are equal differences over equal intervals. Again, I apologize for not going into detail on the paper, but it's all good. 22, solutions. Do you remember what I said about solutions just a little bit ago? I'm going to store each of these into X and then check them. Now you can't store plus and minus at the same time, so I'm going to have to store one of them at a time. Okay, 4 plus the square root of 10. Oops, stored into X. Now if I type in my original equation, x squared minus 8x equaling 10, does that come out to be true? And the answer is no. If one of the answers doesn't work, then I'm not using it at all. Okay, 4 plus the square root of 26 stored into X. That one worked, and I have to check its negative counterpart. So 4 minus the square root of 26 stored into X. Because the positive and the negative both worked, it's got to be choice 2. Okay. Answer choices, choice 2. All right, let me do these off to the side real quick. I've got 1, I've got 4, I've got 3, and I've got 2. All right. We are almost done. That was 22. We've got 23 and 24 left. 23, blood pressure. We're given a formula of F equals P1 minus P2 over R, and we are told to find the formula that cannot be derived from the given function. So there's a few of these things that we're looking for. I see R showing up twice as an answer, so I'm going to solve for R first. To get R equals, I have to bring it to the top. So I'm going to multiply both sides by R. And then I'm going to divide by F. Okay, so I know that R is equal to P1 minus P2 over F. P1 minus P2 over F. It's got to be this is true, okay? That's a true one. Now this one said which one cannot be derived. Well, the fact that this has F up with the P1 and P2 and they're in a different order, I'm going to choose that because I've already figured out what R is supposed to be. Okay, to save myself some time. Last question, number 24. Morgan throws a ball into the air. The height of the ball, we've got h of t equaling negative t squared plus 24t. What is the appropriate domain? So if you look at your choices, domain, we've talked about, has to deal with your input. Okay, domain has in in it. It's just your input. So we're talking about time. All right, so if you look at your choices, again, I apologize for my terrible messy writing. If you look at your choices, it's not 3 and 4 because they don't have just the t's. The second thing you need to know is what this looks like on a graph. So I'm going to type in and remember I can't use t, so I'm going to type in negative 16x squared plus 24x, and I'm going to go back to my standard window and see what happens here. You're going to see a parabola that fills up a lot of the space, but I don't want to use negative time. There's no such thing as negative time. That's why these are starting at 0. Okay. Now, does this graph stop at 1.5 on the x-axis, or does it stop at 9? 9 is way over here. And it stops at 1.5. That's the other x value that it uses. So this would be the appropriate domain. Okay, there you go. That's June 2017, part 1.